problem. It says in an arcade game, we see that we have a 0.118 kilogram disc is shot across a frictionless horizontal surface by compressing it against a spring and releasing it. If the spring has a spring constant of 234 newton meters and is compressed from its equilibrium position 4 centimeters, find the speed with which the disc slide across the surface. So basically what you need to think of when you're working this problem out is looking at the equation. Well, what are we dealing with? We're dealing with a compression of the spring. So basically what we're going to have is we have a potential energy that is elastic. Okay, and once it's released, we see that it turns from potential energy into kinetic energy. Okay, now all the energy that's stored in that spring is going to transfer into the disk into kinetic energy. So we set the equations equal to each other. So we take it, and our elastic potential energy equation is 1/2 our kx squared equals the kinetic energy is 1/2 our mass times our velocity squared. And this is the equation that we're going to be working with. And we're solving for speed. So we go ahead and we solve for this. Okay, since there's 1/2s on both sides, they cancel each other out and they go away. Okay, if we have it on both sides, we're going to divide by 1/2, and I have 1/2 divided by 1/2 is going to give us, it's going to cancel each other out. And so we get, this is our equation. We're still solving for our velocity. And we go ahead and divide both sides by mass. And we see that our mass cancels out. And we're left with our velocity squared. And remember, we're not looking for velocity squared, we're looking for a velocity, so we square root both sides, and we see that we get that. Now we go ahead and we plug everything into this, and we should get something right around, we'll have our velocity equals the square root, our K is going to be 234 Newton meters times our x. Since it's compressed from the equilibrium position, basically they told us how much it was compressed. It's 4 centimeters, but we changed it to meters by dividing by 100, so 0.04 meters all over, and we're going to have that m as our mass, which is 0.118 kilograms, and we should get a velocity right around 1.78 meters per second.